Welcome to the Meltzone podcast from November 3rd, 2018. I'm Tom.
And I'm Stefan. And on today's episode, we are going to talk about tempering PLA, the price drop and change of the Fusion 360 CAD software subscription.
Yeah, we're also going to talk about whether 3D printers have fingerprints, as it has been recently announced in a research paper. And since I've been to Ep3 2weeks ago today, we're also going to, touch on their new products and see what Stefan thinks about the Mortar Beds and the high temperature product range they just announced.
And we're also going to talk about DIY filament making. I got my hands on a DIY filament making machine a couple of days ago, and I'll talk about the first experience I have. And also Tom has one DIY build machine at home where he is going to talk about some of the things maybe he has already done with it.
Yeah, it's interesting stuff. All right, Stefan. What have you been up to?
What I have been up to. So I have already said that I have been working quite a bit with my new DIY filament making machine from Extruder, but we'll get into that topic later.
Oh yeah, there's a lot to discuss on that. It's such an interesting topic too.
It's a really interesting topic, and this has been hooking me quite a bit and has been consuming quite some time in the recent days and weeks. I've also been working with some other interesting filaments, nano diamond filled PLA, which is kind of cool. And I thought I would prepare the video for this weekend, but I think I won't be making it. So yeah, these are the current topics I am working on and I have been working on. So what about you?
What about me? Yeah, recovering from the road trip. It's always interesting, you go out on the road, you talk to a ton of people, you're just gone for a week, but it's 3 weeks in total of effort. But, which is our first topic for this week, I did make a video once I came back about a espresso or cafe W. I don't know. The Italians will correct me here what this is actually called. I'm going to call it an espresso W cup because it fits a double espresso. But yeah, this is PLA. This is tempered. This is the HD PLA from Protopasta. And yeah, Stefan, you've been doing some stuff with tempering PLA too in the coffee sphere of this world, right?
Yes, I have done a video almost 1.5 years ago where I 3D printed one of these Bialetti coffee makers and actually
such a classic.
Got it working on my stove at home, on my induction stove. That was really cool, and it just showed that if you're treating PLA the proper way, so tempering it, it is able to withstand much higher temperatures than you're usually used to with PLA, because usually PLA gets soft at around 50 centigrade. And this is one of the real big downsides of printing PLA. But if you're doing the annealing process, PLA can withstand 170, 180 degrees Celsius. Yeah. And this is pretty crazy. But there are some downsides with it, and I think we have seen that pretty nice in your video, in your time-lapse video during the annealing process, that the parts just tend to warp quite a bit. Yeah. So talking about annealing, people are mixing that up from time to time. There is annealing of semi-crystalline materials like PLA, for example, where during the annealing process, the amorphous polymer chains get in order, crystallize, so you increase the crystallinity of the part, and this is what is helping you with material properties and especially with temperature resistance. You can also temper or anneal other plastic parts, which are actually total amorphous polymers, but there you are only releasing the internal stresses that were created during the printing process. Also can help you with material properties, but this is you need to distinguish these two things. But it's a pretty interesting topic.
Yeah, and I mean, the same thing is happening in the PLA, which is causing some of the warping. I mean, this thing you saw is now kind of oval. This saucer is also very oval because this was printed in that direction. So along the layers, or in the Z direction in printing, it actually grew. Mm-hmm. Because I guess there are internal stresses just from the direction the filament is laid down. So the actual filament tracks want to contract. Mm-hmm. and the material has to go somewhere, so it actually grows in the Z direction. That is also happening when you temper or heat treat PLA. But I mean, the big thing is the crystallization, and these parts, I mean, as always with tempered PLA or heat treated PLA, they are incredibly heat resistant and also quite rigid. Now that of course works well for coffee. You've got your coffee maker actually on your stove, and did you ever measure like what the hottest part of that is and when actually making coffee?
Well, it doesn't really get too hot because the part that was getting hot in my coffee maker was just this big metal washer, but this was all of the time like immersed in water, so it probably didn't get that much hotter than 100 degrees because then the water is boiling.
Water boils and actually cools it back down.
During the design process, I also tried boiling water in like a printed pot, but which I put on my gas stove. This worked up to a certain point, but it didn't really work out all the way. I don't know how hot my machine got, but well, since I also did some temperature resistance testing in the past, it's really the case that up to like 170, 180 degrees, the material stays totally rigid, but then if you are then getting over this maximum temperature, it just gets soft in an instant. Yeah. That's pretty crazy.
Yeah, Protopasta have actually, I think, experimented with selling pre-tempered filament. So don't confuse that with like, okay, you can actually just buy the stuff and print it, and it's going to be a tempered or heat treated part that's going to be super temperature resistant. It's just the filament itself that has been heat treated for machines where you might get PLA clogging because the heat break isn't all that well designed, or it jams somewhere due to heat and regular PLA softening. Now, where am I going with this? Anyways, one thing I was going to ask you is how did you deal with warping in your coffee maker? Because I feel like you've got mechanically interlocking parts, so if those warp, you kind of fish out of water in that case.
Well, this was actually one of the things why I did this video. So I got a roll of Form Futura's Volcano PLA, and the claim of their Volcano PLA is that you can heat treat it, but the amount of warping is minimal. It's just like in the range of 0.1, 0.2, 0.3%. And this is really the case. So the parts came out really only barely warped. All of the threads were still working. So this was something really cool. And before I had been also working with other filaments, and there you have shrinkage rates of like 2, 3, 4%, depending on the brand. So this was a way to get around with that. That's not a standard PLA. This is a modified PLA. I don't know how Form Futura is doing that. I think Protopasta, they are adding some elastomers and other additives to their material, which kind of compensates this shrinking process at least a bit. But you kind of always need to deal with this shrinkage that you have in the end, or not actually even just shrinkage. In your case, it was even, or in the Z-axis, you even have an expansion of your part.
We actually get growth. Now, I guess one thing that people should keep in mind is that the annealing or the heat treating, the crystallization process is something that you can do with pretty much any PLA. My first experiments with crystallizing PLA was basically just standard off-the-shelf PLA with no advertised capacities of crystallization at all, and it still worked, but it still warped a lot. So it sounds like I should definitely try the Form Futura Volcano PLA. Because Protopasta are also claiming that the HDPLA does not warp or shrink or deform a lot. They're also saying like around 1%. It might have been that I've just used the wrong temperatures. I just dropped it in the oven at 100 to 110. I actually checked it with the floor camera, and it might have been too hot. I might have also needed to kind of heat it up a bit more slowly. And actually drop it into a box of sand or something. But Yeah, I think it's a great application if you have the parts that are subject to high thermal stresses and can't print peak, for example.
Yeah, I think you can put really a lot of work into how to anneal your parts. I also did that in the past with thinking about, well, putting it in the cold oven and then, well, heating it up slowly,
Yeah.
putting it directly in there. What kind of platform you are putting it on? Actually, during the last couple of months, and especially with the now removable print bed from the Prusa,
Yeah.
one of the best things that I have found is putting the whole print platform into the oven directly at like 100 degrees Celsius. And this, if your part is still stuck to the print platform, that helps you a lot with reducing warpage.
Yeah, because it still supports the part in a way.
Exactly.
It anchors it down
Yeah.
and kind of counteracts those forces that you get just from the internal stresses relieving.
Yeah.
All right. Yeah. So definitely very interesting topic. And yeah, I'm gonna run some more experiments on the HDPLA, but it sounds like I should really check out the Form Futura stuff as well.
Yes.
All right. The other thing, or the other two news stories, or the actual news stories this week, Fusion 360 price hike, price drop. Stefan, you are using Fusion 360, right?
Yes, I've been using Fusion 360 for the last 2 years, just for the bare reason that it is a really capable CAD program, which is free for me as a small maker. Let's put it this way. So I don't have to use any wares, which would probably be not too good showing that on YouTube. And efficiency is a thing which is really important for me. You can use open source software, but that is just always
free CAD.
Free CAD.
I've tried it. It's
and being used to professional CAD software, it makes it really hard for me to use other software. So I'm totally happy that Autodesk is providing that software at the moment free for makers and for hobbyists and students. I hope this is not going to change soon, but they have already been changing something with their pricing structure for the professional versions.
Yeah, so I mean, the Fusion 360 price model used to be kind of like this. So there was this free version that, as a maker you could use, or as a small business with like limited revenue, you could also use for free. And it gave you a ton of features. It gave you like CNC capabilities and simulation and the full CAD and, a nice package of just stuff you could use. And again, that was free up to a certain company size, I guess. Then there was a basic subscription, which was, I think, around $300 a year.
Yeah.
$310 or so. And that actually had less features than the free one. So that was a downgrade, I guess. If you were using all the features of Fusion 360, you would need to spring for the full version, which was around $3,000 a year.
$1,500.
$1,500?
Yeah.
Okay. How did I mix up those numbers? I must have been like a 2-year subscription or something. So that was a much more expensive subscription, and that gave you 2-year subscription. There we go. That was a much more expensive subscription, but gave you, I think, slightly more features than the free version. So what they've now done, and I guess this is kind of a reaction to Onshape kind of changing their models, their pricing models, maybe, if they even were a relevant competitor at this point. But the professional package of Fusion 360 is now getting cheaper. It is $450 or $500 a year.
Yeah, so that's a
$495.
Price drop of 2/3.
Yeah. So price drop of 2/3. So, but the entry level paid subscription is now gone. So it's kind of like what Adobe is doing, I guess, with their Creative Cloud. Like either you subscribe to the full thing or you get nothing. I mean, with Adobe you can get like individual apps, but really it's kind of all or nothing. So either you use it for free or you pay for it. I mean, I guess it's logical for Autodesk. Probably not a lot of people were springing for the full license, and now they can kind of milk all those small subscribers a bit more, while giving the big fish a price break.
Yeah.
I don't know, but you get more features.
Yeah, you definitely get more features, but I think that I'm not sure how many used like CAD or the advanced simulation tools, which were only available in the more expensive version. So I think it gets a little bit into the direction milking the small ones a little bit more, but still, you gotta say that the price is still quite competitive for what you're getting if you compare it to something like CATIA or SolidWorks.
Even, yeah. And I mean, the thing with like the purchase one software is, you can buy like a full. Let me put it this way: so a full SolidWorks license that does kind of the same thing as the professional Fusion 360 package is around the neighborhood of like 60,000-70,000 euros.
Yes,
that has everything. That has fluid simulation and whatnot. But looking at paying, where are we now? $500,
yeah,
a year for Fusion versus paying 60,000 once. You know, the break even there is not very very good. It's going to be quite a few years into the future. But also, even soft that you buy once have like yearly new versions that you can then upgrade to. And you know, it's kind of like infectious if somebody saves a file with the new version. The old versions cannot open it anymore, even though there might not be anything in there that is incompatible. So you kind of have to upgrade or stick with an older version for so long. So yeah, if you're looking at professional use and what the competition is there, I think it's still a very competitive price. And to be honest, I mean, if you're at the point where you kind of need all those features in Fusion 360 that you kind of don't get with the free version, or you make enough revenue that you have to pay for it, it's not that big of a deal. It's not that big of a subscription.
No, because you need to have a higher revenue than $100,000 a year that you even have to pay for the software, and then I think paying $500 for this tool is totally reasonable. If you're only
0.5% of your revenue, at most,
if you are only taking a look how much a subscription of Photoshop or the full creative suite costs, that's I don't know,
way more for that than
yeah.
Fusion.
Well, we pay around 1,000 euros a year just for Photoshop,
for the privilege
Premiere, and all of the other tools. And well, even though they are really, really powerful, also this CAD software, I think the price is reasonable. It is bad for the small ones, or for the ones who had the smaller subscription, but yeah, I don't know. I think it's still bearable.
It's business as usual. I mean, what are you going to do about it? Switch to what exactly?
And there is no offline version of Fusion 360. That's the thing. Fusion 360 is this cloud-based software tool, and you either subscribe, there is no possibility to just purchase it once, deal with it, or find something different, but everything else which has kind of similar features is way more expensive.
But of course, I mean, it's a subscription, which it has always been. So for Autodesk is kind of, at a position where they can do whatever they want, basically, with their pricing model.
Yeah.
And if you're trained in that software and you're kind of locked into the ecosystem and have all your data stored in there, it's not really easy to get out. I mean, I see the same thing with Premiere. I've thought about, hey, maybe you should buy a Mac and go with a Final Cut, but then it's like, oh, but it doesn't do this one feature that I really like, and that there's a very strong pull factor into that, especially in a professional environment where I don't know how it is today, but a few years ago, like the old CATIA, what was it, 6 or 16 or whatever, the 90s
version 5 release 16, yeah,
something like that, which is 1998 or whatever, was still in use for professional use. So
it is still in use today. I can
wow. So
I can confirm that. But the thing is, it is working. It is used by lots of big manufacturers and companies who have changed to the latest version, for example, on CATIA, they kind of had big problems. So the other ones still staying with the old version. And you got to say, the old R16, for example, of CATIA is not like the more or less latest one, R26, or don't know what it's at the moment. There has been lots of updates, at least in the background, not on the GUI.
Like
and that's
Windows
the reason,
XP service packs, right?
Yeah, like Windows XP service packs. Yeah, it is as it is.
But it just goes to show how hard it is to actually switch out of something once you're invested in it.
Yes, definitely. What really concerned me when you were suggesting this topic was what are they doing with the free version? Because I don't know if there is another competitive software at the moment on the market. Onshape, there was Onshape, which has kind of professional CAD features, but is free to use for students and makers at home.
Yes. So I guess that is the closest competitor. Of course, Onshape changed the licensing so you couldn't use it for any business use, which means I can't use it because my YouTube and making stuff is my job. So sorry, guys, I'm not going to. And Onshape is more expensive than Fusion, right? In the paid packages.
I have never been working with Onshape so far. So
Onshape pricing. So, okay, 1,500 per user per year for Onshape. So, yes, it is 3 times as expensive for the base package, which doesn't have the data management parts of the software. So, just the CAD. But yeah, that is, the closest thing. That there are a lot of like smaller, low price, buy it once and then use it kind of software solutions. But I mean that those might be more than enough for your DIY hobby user. But yeah, it's tough because it is by nature a professional market, a professional ecosystem that you're kind of adapting to a maker or lower end market that traditionally wasn't there. So yeah, it's gonna be interesting.
It's gonna be interesting, and I really hope that Autodesk is continuing using makers and students kind of like free advertisement, because if you are like releasing such a software for free for the ones who more or less would not pay it if it wouldn't be free, but might convince their later employee that this version is suitable to use and they know how to use it, then it's free advertisement for Autodesk, because they might be then the ones who are buying the software, the professional packages.
It's kind of twofold. So I guess what Autodesk are getting from the free version is they get a lot of testing, a lot of work hours put into the software, and they kind of figure out what works and what doesn't, just bug tracking. But for example, what SolidWorks is doing is I don't know, Inventor used to be the same way. I don't know if it's still the case, but they have a free student version that was extremely feature limited. For example, when I was studying, the SolidWorks version didn't even have export to STL enabled. You had to go through the eDrawings viewer. That would be able to export to the STL, but SolidWorks could not do that. So it would brand your designs, have like, this design was created with the student version. So you could not use it for professional use, but you got all the training in for your students. The students learned your software, and then carried that over into their companies that would be working in, and then kind of be comfortable with that, and I guess demand working with that.
Definitely. So let's hope that it stays free. I think the whole maker community is kind of depending on that, and
I'm confident in Autodesk. I mean, I've not been too much of a fan of their software in the past, just because like reliability and stuff. But Autodesk are actually making an effort to be present in the MakerSoft and the Maker Sphere ecosystem. So 3D Meetup Sweden, they were there, which is a super small meetup, and one of the Autodesk guys showed up and just kind of taught some stuff. I think at Bay Area they also, I think they were there with a booth, so they're kind of present in even the low end market where they're not going to be selling subscriptions into.
Yeah, definitely. All right. Let's continue to the next topic.
Yeah, we're making good time here.
Oh, well,
I
we're
hope,
ready.
guys, this is so. As always, we're open to feedback. So
Yeah.
if you guys think we're kind of dragging on too long on these topics,
Yeah.
let us know. There's the comment feature on YouTube, on the WordPress or the website. You can also comment or tweet at us on Twitter, just feedback on duration of these things. But we really enjoy talking about this stuff. And yeah, it's good fun discussing. I hope you're enjoying it as well.
Yes. So
Yeah.
next topic, 3D printer fingerprints.
Oh,
I
yeah.
think this has been popping up, I think 1.5 weeks ago when a research paper was released where some researchers from Buffalo State University, I think Buffalo University, were investigating if a 3D printer, due to its inaccuracies during printing, can be uniquely tracked back, or a print can be uniquely tracked back to the printer where it was printed on, due to more or less the structure of the infill pattern.
Yeah, well, infill pattern, overswings, blobbing, I guess all the artifacts that you're seeing in a 3D print that make a print non-perfect kind of add up to a fingerprint for a 3D printer. And the interesting thing is they are claiming an accuracy of 92%. So they used a set of known models. They printed a few keys and then scanned those basically on a flatbed scanner, if I'm reading this right, and had an automated software kind of analyze that image and map it back to a printer. So that was between 14 different 3D printers, and they got 92%, which kind of sounds impressive. Though, here's the question, Stefan. You've actually been reading the paper, right?
I have been browsing through the paper, and I've been reading some of the sections. And actually, when I have been taking a look at the paper, I noticed one of the pictures which directly drew me off when I was trying to read it at first, like 1.5 weeks ago. Sorry, continue.
Yeah. Cool. The question that I have with that is 92% out of 14 printers. Is that actually so that they're using 14 different 3D printers? So that is 14 unique 3D printer models. They cannot, from what I'm reading, is they cannot distinguish between 14 identical printers of the same model, which one it actually printed. So say there are, thousands of Prusa machines or Ultimakers out there, or, Ender 3s. You wouldn't be able to tell which Ender 3 this printed. You would just be able to say, if the world was just 14 different models, you would be able to say, okay, I have a 92% confidence that this was printed on an Ender 3, but not on this particular one, right?
Yes.
Okay.
Just one first thing. The 92% was actually even after they were scratching the parts, melting some of the areas and things like these. Their first confidence was, I think, even 99%. So a really bold claim. But getting back to your question, I have actually been looking for this statement, and I didn't really, from what I have read so far, any statement where they said they can distinguish between a printer model or a unique printer. And I think, as far as I have understood it so far, if they are talking about this 92 or 99% accuracy, they are talking about printer models. So you could say this part was printed on an Ender 3, but not on which of the 100,000s of Ender 3s that there are currently on the planet.
What you should also keep in mind with that is for, I guess, one set of print settings. So, not just layer heights, but even acceleration settings and, well, maybe not infill settings, but speed settings, for example. I would think that if you change a single parameter, like you change your acceleration or your print speed even, this wouldn't work anymore.
Yes, but I think they are talking a little bit about that they want to more or less increase their database, and they are not only looking at at one specific parameter of the structure of a print. They are looking at several. There are let me check. There I think even around at least around 10 different parameters like structure, like overswing, and things like these, in order to make their algorithm more precise, so that they might be able in the end to say, even though some of the settings have been changed, this is still an Ender 3 where it was printed on.
Right.
Since you have many things you can correlate against.
Yeah, well, I mean, what I'm thinking about is, for example, you did some testing on printer frame resonances at some point, right?
Yes.
That could very much play into that, because every frame design kind of has its own, characteristic resonant. Frequency. What is it? Frequency range. Well, yeah. It resonates in a very specific way. Let's put it like that.
Which changes with the amount of filament there still is on the spool.
Right.
Yeah.
Right. Oh yeah. So
but if you take a look at different printers, and so they have been comparing an Ultimaker, a MakerBot replicator,
to XYZ Da Vinci,
and an XYZ Da Vinci. I don't know if they are totally. They are quite different with their kinematics. And
so wait a second here. So what I'm seeing here in the list is they have 3 Ultimaker 2 Go's. Yes. They have 1 Ultimaker 2 Extended Plus. They have 2 MakerBot replicators. They have 2 Replicator 2X. They have 2 Da Vincis and 4 Formlabs machines. So this would suggest, if that is, I mean, this is 14. I'm taking this as their sample set, so they would be able to correlate it, or to distinguish between each of the MakerBot replicated 2Xs, for example, or the replicators, or the 3 Ultimaker 2 Go's.
I have been searching for that statement, but the 15 minutes or 20 minutes I spent on that paper, I did not find a statement where they specifically said that they can distinguish between. They are always talking about they can distinguish between printers, but does that mean a type of printer, or a unique printer itself? And
of course, I mean, identifying the prints that are printed on an SLA machine, I think that would be kind of trivial if you compare them against the FDM prints, you know. But yeah, the more data you have, the more printer models you drop into this, I think that the less good your recognition rate is also going to be, simply because some printers might be very similar in printer output, just because, you know, they're very, very similar machines. That could play into that, and yeah.
But I think, since they're not only taking a look at one specific parameter of print quality, they still might be able to still distinguish between like even slight changes in like different belt manufacturers or different roller manufacturers. I don't know. I think the approach is not too bad that they did there. I still have to read through all of this to get to a full conclusion. But yeah, I don't know. I don't know if this is worrying for us. So they're stating in the beginning that they are doing that to help investigators find, for example, manufacturers of 3D printed guns or
which right
counterfeit
now isn't really
parts.
An issue, but might be, yeah.
So the question is, if they are just distinguishing between printer models and there is a 3D printed gun found which was printed on an Ultimaker, does every Ultimaker owner now gets into, the range of suspicion?
Yeah, it definitely has some implications. I mean, I'm also seeing the other side. Like, if you just create a table or a software solution for identifying, what a print looks like, you could also use it in a different way to optimize your printing performance, for example, and just to see, okay, this set of parts that is on this printer, we can map this against, okay, these print results we're getting, and kind of, neural networks, machine learning, all that. You know, kind of go in that direction and say, okay, we have this ideal combination that we can make from the results that we're seeing here, and build a printer from that is actually better. But yeah, I think the identifying part of this is maybe a bit overstated in the research paper, as you know, research papers kind of need to be to draw attention and to kind of make their funders happy. But yeah, it is kind of obvious if you look at it. I mean, you show me one print from an Ender, you show me another print from an Ultimaker, I'm going to tell you which is which. As simple as that. Having that in a machine model is nice, has some potential, but I'm not too worried about kind of getting tracked down if I print something and give it to someone that they're not going to know, hey, this guy printed this on that machine.
Yeah.
At least not in the near future.
Yeah. I think the approach is interesting, and the idea behind it, helping investigators, like getting this fingerprint, like the ridges on a bullet that was found in a victim, and tracking that back to the gun.
Yes.
So the comparison to that is really interesting. I really don't know if how the applicability is if you are having like 100 different printer models with like 100,000 different people who have that printer.
Yeah. And at its core, 3D printing is still a very messy process, right? It's not like, a barrel of a gun where it's like super precisely machined and you have, everything is under control. 3D printing very much still is. Hey, we got some plastic, let's throw it in this thing, heat it up, and throw it down onto a plate.
But this is actually the point behind that, because also the barrels in a gun, they are not 100% perfect, and not every one is the same, and this is what they are using. If 3D printers would all be the same and would produce the same results, you would not be able to distinguish them. And this is all what is in the background. They're basically using the imperfections of the printer in order to identify them. Yeah.
True. Interesting stuff. We'll see what comes from it.
Yeah, definitely. So everybody who's interested in that paper, we have linked it down in the show notes. You can take a look at that, or just Google for 3D printer fingerprint, and you'll find plenty of news reports about that from the last couple of days and weeks.
Though you will also find reports for actually printing fingerprint replicas to full fingerprint scanners.
You did some research?
Yeah, I tried Googling for that, and I was like, this is not what I wanted, which is also very interesting thing, and it might also come into play with the 3D printer fingerprint technology, where you can actually track that 3D printed fingerprint back to a 3D printer with the 3D printer's fingerprint. Do you know what I'm getting at?
No.
Okay. Anyways, let's move on.
Yes, let's move on.
E3D, how are we doing on time?
Yeah, I think we are still in time, but yeah. So you have been on your road trip all over Germany, the Netherlands,
the UK.
and the UK. And you have been visiting E3D for 2 days, all in all. Did an interview, did a podcast there, and you have seen some pretty interesting products.
Yeah, so I've seen some things that I cannot talk about, which is kind of the nature of, doing a factory tour and kind of hanging out with a research-focused company. But the stuff that I can talk about, and the stuff that has actually been announced, is, for example, the Mortar Beds, which is an aluminum plate with a silicone heater, which doesn't sound all that impressive, but it is kind of, first of all, it is a crazy powerful heated bed. It has a ton of heating power. It has 500 watts for the standard 200 by 200 size. So that is, I asked them, hey, how quickly does it heat up? And it's like 30 seconds to a usable print temperature. So that is crazy. But the big thing about it is that it is vulcanized directly onto the silicone. So it doesn't use that adhesive layer, which stands up to 150 degrees maybe safely. I've tried that. I tried cooking some sausages. The adhesive bubbled up, and now I have like a huge bubble on the bottom of my heated bed, which makes heat transfer kind of hard. But yeah, so that's the big deal with the mortar bed. They are AC powered, so you hook them up to your mains voltage, so you do not need a more powerful power supply, but you
But
do need an SSR.
and you should have kind of some knowledge about electricity to not electrocute yourself.
Yeah, hook up ground and kind of use a ground fault switch. Um, good practice. As soon as you're dealing with mains voltage, be
Yeah.
safe. Ask someone who knows their stuff. And the other high temperature announcement was high temperature heaters. And the announcement that they're working on higher temperature nozzles where the entire annealing process comes into play again. But the heater, just more power, more heat resistance. Stefan, you've been liking some details about that one very much.
Yes. So, well, I have seen the pictures of the new heaters, and the thing which I would be really keen to have also on the normal standard heaters is the 90-degree bend directly of the wires coming out of the heater cartridge. So I have plenty of heater cartridges on all of my printers, and on all of them, the wires are directly bent after the heater cartridge, and I'm always scared that they get ripped off or just bend and break. So this is something really nice to see.
Yeah.
On these, and this is the non-standard part, and I think also the heat resistance, they can be used up to 500 or 600 degrees for a longer period of time.
Very hot. Very hot. I mean, the standard heater cartridges would just burn up at some point. They would just go open circuit and not heat anymore. And yeah, I mean, both these products are basically for printing PEEK, and E3D are working very heavily on making PEEK and the entire PAEK range of materials more printable. And these are products that basically they need for that. It is solving a problem they have, which is the best kind of product. If you can't just develop into a vacuum and say, hey, we've got this new fancy thing, it does cool stuff, but we don't really know what to do with it. No, they've got a very specific application for it. The mortar beds, I mean, they are kind of pricey for what they are. If you don't need the super high temperature resistance, you're better off, or cheaper off at least, buying a regular sticky bed and sticking that onto something. Same with the heater. You can use a standard heater cartridge for standard materials, but as soon as you kind of go into experimenting with the more high performance materials, you kind of need that. There is no alternative really out there.
So I'm currently on the blog post that they have released like a week ago. 65 watts in comparison to the standard 30 or 40 watt heaters you're having on the standard printers. So that's, like a factor of 2. You probably don't need that for working at these higher temperatures, but that makes heating up the cartridges, way faster.
I mean, if you're printing at something like 450 degrees, you do kind of need the extra power.
But
not necessarily to get up to temperature, but to actually regulate the temperature at that level, because you need a bit of overhead just to keep it, at temperature when a bit of air sweeps over your block or something. So,
you're probably right with that.
It might still be on the low side actually of power. You might be able to drop more power into that.
Yeah. But it's always nice to have this extra wattage that you don't have to wait for like half an hour to get your heater cartridge or your heater block up to 400 degrees Celsius to print your PEEK.
Yeah. So that's nice. And I mean, heat up speed is such a nice, comfortable thing to have. I've had that in my DIY Delta, where the heated bed is just up to temperature within 3 or 4 minutes, and it's just so nice because you go down there, you hit start, and you can wait for the first layer to go down. You don't have to wait 20 minutes on something like a CR10 or 30 minutes for the build plate to get up to speed, where you can basically make yourself a coffee and have a sandwich in the meantime. You can actually stay with your printer and watch the first layer, and then you can take off and be confident it's actually going to turn out well.
Yeah, and that is really nice. And so they are aiming more towards, businesses with all of these products. And for them, time is money. So having a printer that heats up faster is like money saved. So it's a good thing to go into that direction and to have a reputable manufacturer providing these parts at a really reasonable price.
Yeah. And I mean, you got to keep in mind, these are not high volume parts. Something like a PCB heater, that's tens of thousands that is just being churned out. These beds that E3D are making, first of all, they are more expensive to make simply because it's a different process, but it's also not the volume of not the scale of products that you have with something simpler.
But
so for that,
still they are, for the small bed, they are just around $100. So
it's decent if you compare it to getting a machined aluminum plate and a silicone heater. It's all right. It's like twice as much, but yeah, for what you're getting, it's it's expensive, but it's all right.
Yeah.
It's a niche product.
Yeah. And you've also been talking about the whole ecosystem, which is connected to, Printing Peak and things like these. So they are also have been releasing the new heater blocks, or is it just the Volcano heater block in copper, or the...
So copper heater blocks have been out for a while.
Yes.
So that's if you ever see a really nice, shiny, laser engraved E3D block, that's the copper blocks. I've had one for a while. I've not used it because it's so this looks so good. Every time I show an E3D hot end, that's what I show. So they've had the copper blocks and nozzles for a while. Both are nickel plated, which is why they're so shiny. Raw copper just looks like grog after a while if you just leave it to oxidize in free air. And I believe there's also the Volcano heater blocks in copper. Not sure how long those have been out. The other thing they've shown is actually the Supervolcano.
Yes.
So that is that is very, very nice, which has been announced for a while, but it's kind of getting into the last stages of being turned into a product. And that is an exclusively copper block as far as I know. So it's like twice as long as the Volcano. It is super heavy. It's got nozzles that are crazy long. And it's also got a super long heater cartridge. So that is just you throw as much filament through this as possible. Whether or not you actually need that, I don't know. Tests will need to show that, but it's nice to have the option.
Yeah, with the Supervolcano, it's probably only useful if you are using really, really big, nozzle sizes, where you need the length of the nozzle to get everything melted. I don't know in which case you would need such a big thing and where a normal Volcano would not be sufficient. But it's nice to have that. And as Sanjay has always presented it in his blog posts and in videos, it is one of the projects he really like to work on, even though it's probably not the most... the most necessary thing to work on.
Yeah, for sure. And it is. I mean, I've seen the scale of the company. I've got a company tour coming up pretty soon. It is growing quite massively, and they've turned into quite the professional company. It is scary to see them go that way, but it's good to see that they still can work on stuff like that, where it's not just, we need to, shave the last 2 pennies off of this nozzle that we're making and make a bit more profit. And it's not about over business optimizing things. It's still about making products that are maybe fun, maybe maybe practical in some ways, but they still enjoy what they're doing. So I think that's a good recipe.
Yeah, definitely. And I'm happy that they can do that, because these are the guys who also still innovate and are not just copying stuff. If there wouldn't be E3D, we would miss many things, like all of the V6 clones, for example. So it's good that they are still able to be a business in maybe a quite competitive market as well, with all the
for sure.
Chinese clones and rip-offs you are getting nowadays.
I mean, maybe someone else would have come along and taken up that void that E3D, if E3D never existed, would have taken. But
Who knows?
it is how it is.
It is how it is.
All right, time, dude.
Yeah.
we should do this. Really, we should really do this on a bi-weekly schedule. Because if we skip a week and it's been a month to talk about stuff, that there's just so much to talk about.
Yeah. But well, just maybe without further ado, let's get to the next topic.
Yeah, let's just keep working through this.
Which I have been teasering before. So
yeah,
it actually started a year ago when I was at TCT Forum Next, and I have seen one of these small filament making machines there were. And since that day, I started gathering old PLA prints in big buckets behind me. And I always wanted to get one of these filament making machines for myself and try to make recycled filament. Just the big dream. Taking all of your scraps, taking all of your failed prints, supports and stuff like that, grinding it up and make new filament out of it. So almost, I think, half a year ago, I ordered a filler extruder from Filler Extruder, a US company who did a Kickstarter quite some years ago for a filament making machine, which is like pretty simple. It's only a windshield wiper motor. It's a water pipe, a metal water pipe, an auger, so like a big wood drill, and a nozzle in the front with a heater. You put pellets in there, it melts, and it extrudes into filament. Basically.
Well, that's what an extruder is, right? At any scale.
Yes. So
maybe not with a wiper motor, but an auger, a heater zone, and some nozzle up front.
Yeah. So this package was sitting in my basement for like 2 or 3 months now, and I just did not have the time to work on it. And just last week I started assembling it and playing around with it a little. And well, the building process was not as pleasing as I hoped, I gotta say. But after a while it turned out and it makes filament. I started with pellets that I got from Form Futura. So really like, I think that was just chopped up filament.
Well, that's what typically that's what a filament or master batch starts with.
Yes.
If you pre-blend it through a compounder, it's basically an extruder, and then it's getting chopped either hot or cold. So yeah, many raw resins or pre compounded resins are exactly that. It's filament that has been chopped up. Yeah.
So yeah, I made my first filament, printed a Banshee. Worked fine so far. Just like 2 days ago, I thought about how can I shred some parts and get more or less the base material for extruding filament. So I modified an old shredder. I tried using a mixer and things like these. Sift the material which came out of these machines to get it to only get the really small particles that really fit into the extruder screw. Dried up everything, and yesterday I made the first run with like 50% chopped up material and 50% like virgin PLA pellets, and it worked, and it was kind of nice. There are still problems with the whole setup and inconsistencies with diameter, and it's still lots of tinkering around, but like a proof of concept, it was so nice to see that I have been taking my scrap parts and making new filament out of it, and just printed another Banshee there. And doesn't have the most consistent colors, but yeah, if you are chopping old material with different colors, that's just what you're getting.
That's what you get, yeah.
But it looks perfectly fine. Really, really nice. So
yeah, I guess let me see. My background in filament extrusion is a few years ago, so like 3 or 4 years ago. I built my own. I tried to build my own. I got some filament to extrude. It printed perfectly. It was really nice filament. And that was probably like twice the size of a fill extruder. So 20 millimeter auger, also stainless steel pipe on the outside, 3 heater zones, all that. And the stuff I struggled with was, first of all, the torque needed to drive that auger. I tried with wiper motors. Wiper motors didn't work. I have like those big black tin or can kind of types, not the geared ones, or they're also geared, but they're not warm geared. But they don't have that same construction as the one in the fill extruder. I struggled with that. I actually did not struggle that much with filament diameter consistency, because I think, at the time while I had the motors working that I had before they burned up, they were turning everything really consistently. But I did struggle with getting the entire thing started and getting it spooled in some way. So I guess the first question for you as a fill extruder owner is like, what is the size of the auger? My size of 20 millimeters was based on like best practices for extruder design. So 3 times the diameter of the pellets, which probably was way too large. What is the size there? And
I
how
think
is torque
it's like
holding up?
12 or 16 millimeters, something in that range.
Okay. So way smaller, way less torque requirement, obviously.
Yes. So the motor that they are using, it's not a warm gear motor. It's a with normal gears inside.
Okay. Spare gears.
Spare gears,
Weird.
step down, and the power requirement usually is around 12 to 20 watts. So it's not a really huge motor, but well, it's running on 12 volts and usually it draws around 1 amp. But I had actually problems in the beginning, and depending on the temperature you're using, depending on the pellets you're using, depending on the accuracy in the machine. So I had some burrs in the beginning, so I used files and everything to get the pipe really nice and clean. I don't use any, it doesn't use any stainless steel pipes. These are really bare, just like cast water pipes, really nasty on the inside. And it took me quite a while to get everything smooth and running. But now if it's running, it's working quite nicely. The thing, and this is the difference with a professional filament making machine to a, like fill extruder. The diameter of the material is a result of extrusion speed, gravity that drags the filament downwards, temperature in the room, cooling, fans positioning, and all of the things which are connected to that. In comparison to a normal filament making machine where you have like one standard nozzle size and you kind of draw the filament to diameter.
Yeah. And
you have measuring devices in there, and they are constantly measuring the diameter of the filament. If the diameter is too big, they are just dragging a little bit more on that extruded piece of plastic. If it's too small, they release the drag, and this is how they can really control the diameter.
Yeah, and really in the big extruders, your drive gear for your auger is just so oversized that basically it is running at a constant RPM. Even if a pellet gets stuck somewhere, it's just going to chew through that. Or if you have an air bubble that needs to escape, where it would have less resistance, it all just, it is a very consistent RPM on that auger, which I guess is a very consistent pressure in your melt chamber. I mean, the fill extruder has no sensing or feedback loop at all. There's no diameter sensing. There's no RPM control on the motor. It's
the bare minimum that you're getting. And I also need to point that out. This is not a machine you buy yourself, build it up, and then produce filament. In my opinion, it has lots of tinkering involved. It, in my opinion, doesn't make you less expensive filament, because buying 1 kilogram of PLA pellets here in Germany costs you around like 8 to 10 euros. This is which is surprising, but also not surprising if you actually package it into small little bottles and ship them out individually. Yeah, if you buy the resin maybe in bulk, like half a ton, it's probably like 3-4 €4,
3 to
something
4
in that
euros.
range.
Yeah, the NatureWorks stuff is I think, somewhere around that ballpark. Standard polymers, PP or ABS, like $1 to $2 per kilogram. Yeah. If you buy them in a big bag, which is 500 to 1,000 kilograms.
Yeah. So
I've actually looked at those prices.
Only if you're really using or needing a huge amount of filament, it might be cheaper for you to make your filament yourself. But most of the time, it's the fun of tinkering around, and it's the fun for me trying out if I can use my old filament scraps and make new filament out of it. Yeah. This is what makes me happy, more or less. And getting that to work, and maybe getting that to work better than others did before, and also showing that to other people. I think this is the really cool part about that. Even if it doesn't make me, cheaper filament, if it's not the best filament in the end, but just doing this proof of concept. And maybe there's somebody out there who gets everything together in one big machine, and maybe in the future there are cheaper machines available that can turn your scraps into working filament, or directly extrude the scrap parts into your 3D prints.
Yeah, so that's actually something that would be interesting. So the fill extruder, looking at the pictures, did you have a picture posted? Yeah, so it's set up vertically, so it is actually extruding like a hot end. It's actually dropping down the filament, right?
Well, in the standard configuration, it's horizontal. I also mounted it on a wall that it works nicely with the filament winder and everything. So it's more or less working like a hot end. And I think there are pellet extruders outside, but just working with this fill extruder and now just slowly getting to know all of the issues with filament extruding, talk of the auger and everything, I think it's kind of hard to get a pellet extruder at a reasonable price working on a 3D printer, and then also taking into consideration all of the additional mass you need for that.
Yeah. Well, with a hot end, you don't just need consistent diameter. Well, you actually don't need consistent diameter.
You need consistent flow rate.
You need consistent flow rate, exactly. So with a filament intermediary, basically, you have that diameter just as your base parameter, and if you use it as a hot end, you just need to keep the flow rate very consistent. So definitely a challenge. There are some printers that use a direct pellet extruder. What is the one that is like container sized? Some Dutch companies, I think attached to Ultimakers, somehow they built like a container sized 3D printer and directly feed pellets into the thing. Very crazy concept, and definitely has a high output at a low cost. So that's that. What do you think about the idea of kind of not worrying about diameter tolerance at all, and kind of keeping it at a size where it's going to fit through your hot end, and then compensating in your 3D printer for it?
I think sensor. That is a really interesting topic. So maybe to talk about another thing before. So Prusa is claiming really small tolerances with their new Prusament filament.
Yeah.
I think I wasn't really that consistent with my filament, but most of the parts turned out pretty well. So I think our printers are able to cope with some variation in diameter, even though this means plus minus 10% in material that is being extruded.
Yeah.
But if you are working on really small parts with high precision, tolerances might be important, and then having a filament sensor before your hot end, measuring the diameter constantly and adjusting your flow rate depending on the diameter might be really interesting. And Marlin is in theory capable of doing that, but there aren't really a lot of filament sensors around at the moment.
I don't know if we've talked about this guy before on the podcast, but small project there, which is a inline filament diameter sensor for less than $10. I should definitely make some video about this. But yeah, I do have one of these. So the tech is there. We can do it. We can compensate for it, and it's neither complicated nor expensive to do. So that might actually be an approach to maybe in the midterm kind of drop down filament prices. Because right now, I mean, as you mentioned, filament or the pellets themselves, the resin itself, isn't that expensive. You pay, $20 per kilogram of filament, let's say from a manufacturer, and most of that goes towards manufacturing. So if you could drop the cost of that manufacturing down, or shipping and marketing, and everyone wants their cut. If you can make it or get to a more direct market and sell or produce directly, and then use small stuff like this to use even shitty filament, let's put it that way, because that's what it is, right?
Yeah.
If you have like super sloppily manufactured filament, if you can still use it and still get great results, that would be nice. It's gonna need some time to get there. Now on the topic of directly printing with filament that maybe has like plus minus 10%, if you have even good filament, if you tune your extruder to be minus 10%, so 10% under extruded technically, it's still going to print fine. It's still going to look very, very good. In fact, it might even look better than a machine that is set to the perfect diameter or to the perfect flow rate, but the parts are just not going to be as strong. So you're going to see some deficiencies in top solid layers where they might droop or have holes in them. And also simply because you don't have that much material, you don't have that much fusing and contact surface in each layer, you don't get the full strength of the material.
Yeah.
But it is definitely printable as long as it's not too large and clogs your hot end, for example.
Yes. It's a really interesting topic, and it's lots of fun for me just working on that and seeing how it turns out, even though I know, it's not economic. It's cheaper to throw old material away and purchase new one. But as I said, maybe somebody else could turn that into a business if it's more accessible, if some ideas are spread, if you discuss about how to even further improve processes you have at the moment. And I know, I don't know. As I said, it's fun for me to work on that at the moment. I need to work on fun stuff because otherwise, it's hard to make videos about things you don't really like.
Exactly.
And maybe there's some other tinkerers around who just want to play around with that, maybe find it interesting to produce their own filaments, maybe do some kind of compounding themselves to get custom colors and all of the things which are involved to that. And maybe for these, a filler extruder might be something interesting, but I just need to point out at the moment that it is not a perfect machine. You can buy, I think it's called a filler bot. Well, you can buy more advanced filament extruding machines, which are just like 2,000, 3,000, 4,000 euros. And these ones will make you, material in a consistency of any other filament you can buy at home. You can buy online. But the costs are higher. I don't know.
How much was the filler extruder for you?
So I have the filler extruder and the filler winder. I think it's all around $500, and then shipping plus import taxes.
Yeah, of course.
It got a bit expensive at the customs.
So you should definitely not do that if you're looking for a return of investments.
No, it's a fun tinkering project, but there is lots of tinkering involved.
Just like 3D printing, right?
Yeah, but
totally fits in.
I also have to point out, I think all of the parts are open source for the filler winder, filler extruder. I'm not 100% sure about that, but there are open source filament extruders online, and the parts are readily available in your hardware store, market, and online, and you could even build one from scratch, just as you did it.
Yeah.
Well, and you have an advanced one with like 3 heating zones and things like these. This just has one.
Control. Yeah, very simple design. I don't think you need much more than that. If you really tune it into one specific extruding parameter set, basically, then you can make some very usable filament with it.
Yeah, definitely. Yeah. So interesting topic. I'm I still need to put quite a lot of more work into that, but hopefully in the near future I can show some of my results also with the other guys on YouTube and release some videos about that. I think it will be interesting.
Yeah. And you so far have been extruding PLA, right? No.
Well, I started with like 1 pound of ABS just to clean the auger and the pipe.
Right.
And then switched over to PLA. And I'm now only working on PLA because this is the material which I use the most. But I gotta say, I think about trying to like collect bottle caps and maybe do some low density polyethylene filament with that. I don't know if that works or if that's printable. But
we don't have milk jugs here in Germany, unfortunately. So that apparently is a good source of HDPE or LDPE.
LDPE, yes.
Low density, yeah.
Well, the bottles would also be, but since they are 25 cents. The regular hot bottles, as the Brit says. So soft drink bottles. Yeah, it wouldn't be a good deal to use old bottles and turn them into filament because they're recycled anyways.
Exactly. They're recycled on an industrial scale, and I don't think we can one-up that.
No.
in a small setup like this.
No, not at all. Yeah.
Yeah. Well, if you need ABS resin, I've got like a full 25 kilogram bag still of some what is it? 9-4. Crap, what is it? Some Samsung, basically subsidiary of Samsung. 94S. Not sure what it is, but it prints really well. If you need it, it's just taking up space here.
Well, if you have PLA, I'm open for that, but well, I'm not a huge fan of ABS, so
I can send you some failed prints if that's something you're into.
Well, as I said, I have buckets full of them.
Yeah, and your shredder setup, I guess last topic for today.
The shredder setup is just like a paper shredder I bought like a week ago at Aldi. It's a 10 paper piece shredder, which I cut open a little. It's horribly dangerous now. I added some 3D printed parts just to make it a bit more safe. But this is where I can shred a little bit bigger parts. I have a smoothie mixer where I can put smaller parts in. And I'm also thinking about using a wood grinder, the thing you use outside for shredding your garden stuff to break up bigger parts of prints.
Yeah.
And Häcksler. As I said, I'm still totally in the beginning, and I need
wood chipper.
Wood chipper, yeah, exactly. I need to see how I can work with that. The setup I have so far worked pretty well for most of the support structures I had, but yeah, we'll see. I think the way it's going to be interesting. So not like the end result, but what I thought about, how I approached it, and what I got out in the end. I kind of want to show that in something like a video. So also to make sure that people understand that this is not a fully working process at the moment, and they say, oh, I bought myself one of these filler extruders and it doesn't make filament, and how do I even turn it on, and whatever. It's a tinkering project.
Yeah, well, it might not produce the bestest, most glorious filament, but what I really think is great about it is it does produce filament, it does produce printable stuff,
yes,
which
definitely.
You've shown, so that's great, and it opens up that route for experimentation, whether that's just with colors or flakes or particles you mix in with stuff, or even just making new compounds, mixing or copolymers, not copolyesters, just experimenting with material compositions, which is something that traditionally was not accessible to the small user, the end user, the 3D printer user, the maker, and it's kind of like monkeys on a typewriter. You're going to have a lot of failures, but eventually you might find something that works better than PLA or better than PTG, or is just a good new material that you can use. And if that catches on, hey, that's a win for everyone, right?
Yes, definitely. Yeah. So we are already like over an hour in.
Very well. So we're going to skip our last two topics. We have more to talk about next time.
Yes.
Yeah. So as always, thank you all for listening. That's weird to say, but we're also going to skip questions for this week's because we don't really have that many. So if you have questions that you want answered from us too, leave them as a tweet at us at the Meltzone. Leave them as a comment on YouTube. Leave them as a comment on the website. Yeah.
The podcast should be now available on more or less everything besides Spotify.
People have asked for Stitcher and for Google Play Music.
Okay.
So those two. So Google Play Music, I don't think is reading the iTunes library, which doesn't make a lot of sense. But Stitcher, I don't know how that works. We're gonna look into that. We of course want to be available everywhere, on as many places as possible, just to be as comfortable, as easy to listen to as possible. Yeah.
So thanks for your time, guys.
Links and stuff we talked about in the video description or in the
show notes.
Show notes, yes.
Show notes.
And see you next time. See you in 2 weeks, Stefan.
Yes. Bye.
Good talking to you. Bye.